Hello, chemistry students. Today we are going to be talking a little bit about combustion. Not a lot, but taking a look at one of our favorite reactions can help prep us a little bit for our finals. And so we'll go ahead and take a look at the candle that we got right here. The first thing that I wanted to do is get an initial mass of the candle. We want to burn this thing for a while, and we want to be able to figure out how much of the candle we actually burn. So in order to do that, we want to make sure that we weigh it in the beginning. So let's go ahead and just get an initial weight before we begin. Let's record that down there. Sorry for the glare, a lot of glare this morning. Okay, there we go, 46.46 is our initial weight. Now when we talk about a candle burning, there's actually a couple things going on that a lot of people don't think about. When we talk about combustion, a lot of times people think that either this wax lights on fire, or they think that it's the wick that's actually burning. So let's go ahead and take a look at this. So we'll go ahead and we'll light the candle wick here. And so when we light the wick, you'll notice that it's definitely not the solid wax. Like if you really get down at eye level to the candle, you can see that the flame is hovering above the wax itself. Now when we first light it, the flame was kind of short, you'll notice, and the longer it burns, the flame begins to get more height to it. If you look closely at the flame, you'll also notice that there's a bit of an arc to it. Like if we kind of come in from the side, it's a little difficult to see here. There's a bit of a dome that appears here, and the flame itself is actually not really touching the wick. The wick has got a little bit of a curve to it, and the dome comes right over the top of that wick. It might be touching just barely slightly right at the end over there. But this is kind of an important observation. If we were actually burning the wick, it would be the equivalent of burning a piece of string. And if you've ever lit a piece of string or something on fire before, it burns up really, really fast. And this is not happening. Now, another observation that we could make is you'll notice that the wax, it starts to get kind of a bowl in here. We see that the heat of this flame is melting the wax, and it's creating a bit of a puddle in there. And we can see that some of it is sort of dripping down the side. So the solid wax itself is not actually on fire. The flame's not touching it in any way. And so there's a couple of things that happen. When we have a combustion reaction, think about the demonstrations that we've done in class to see combustion actually happening, right? We have always tried to take our hydrocarbon. And so what would the hydrocarbon here be? Well, the hydrocarbon's actually the wax. Okay, this is full of C's and H's. But we can see that the wax itself doesn't appear to be on fire. But the answer to this is, if we go back, the answer is in that dome right there and in the shape of our flame. Notice that as we go up, it's very difficult to see on the camera. It's not doing a great job distinguishing the colors. But it gets brighter and brighter as we go up to the tip of the flame. We can also see that it's more of a pyramid. And so what we actually have occurring is we initially light the wick of the candle, and once we light the wick of the candle, it begins to burn for a second or two. Then once it begins to burn, it tends to start melting the wax all around it. And when you melt the wax into a liquid, that liquid can heat up and turn into a gas. That's the key. It's a gas. So if we sort of look at a piece of paper here, if you picture, you have your candle. This is not showing up very well. You have your candle, you have your wick. So all of a sudden you get sort of a puddle of liquid here, and that puddle begins to heat up and turn into a ball of gas. Now, if you picture a ball of gas right here, it's very hot. And what do hot gases do? They rise. And so as the gas rises, it catches fire and that ball of gas burns to a smaller and smaller ball of gas. And you'll notice what we start to see here is that real characteristic flame color that we see on the candle right here. Okay? And so it's actually only burning on the outsides. Since this is a ball of gas, this is my pure hydrocarbon here. But we know in order for something to burn, you also have to have O2. And the O2 is surrounding the candle flame. So the hottest edges of my candle flame are actually, or the hottest part of my candle flame is actually along the edges and up at the tip. This is where we're getting most of the perfect ratio between our reactants. You can actually see that it's the gas that is being burned and not the solid itself. If you blow the candle out, when we blow the candle out, you tend to see the smoke from blowing it out, and you can actually bring the flame close to that smoke. Let's see if we can get this on camera here. I don't know. So we'll light the lighter. We're gonna blow the candle out, and then you just stick the lighter into the smoke, and you'll see that it'll jump. See if we can get a better angle on it. So we know now that a candle burns by actually igniting a gas, not the solids, not the solid wax, not the liquid wax even, not the wick. The wick is just there to get the fire started. We can see this a little bit better with a Bunsen burner. So let's light a Bunsen burner real quick. And if we sort of get down closer to the Bunsen burner itself, you can look closely at the flame and you can see where the flame is actually lit. Just like the picture I drew, as that ball of gas rose, that's exactly what we have here. We know that we have a gas coming in through the tube. The gas is lighting here, and it's actually only lit along the edge because this is where the oxygen is, this is where the methane is, and so where those two reactants can come together in the right stoichiometric combination is where the fire begins. So we can see that as we light it, it comes up, and that ball of gas will take on the same characteristic flame as a candle. As we come up to the top, the ball of gas gets smaller and smaller until it comes to a point where it's just a tiny ball. Now, when you look at this, you can prove that this is a ball of gas and that it's only burning on the edges if you just take a piece of paper and stick it in the flame. Now, if we light the paper by just sticking the corner into the flame, it's going to burn right along the edge and go in. But if we stick the whole entire thing into the flame, you'll see that the flame is hollow. So if we stick it right in, you can see exactly the pattern that burns from this thing here. So when we burn, we could see that it ignited only along the outer edges, and then it would have moved its way in. But the center of the flame didn't light because there actually is no fire in the middle of our Bunsen burner. It's only along the outer edges. So we have this lit ball of flame, and it's rising up, and the ball gets smaller and smaller and smaller. All right, so we're back over at our candle now. It's had a chance to burn a little while. And so if we zoom in on it, we can see if this thing will refocus. There we go. A pretty good lake of wax at this point. So as we kind of move around it, we can see that that wax has melted. It's still roughly the same amount of wick because the wick itself is not actually on fire. If this thing had been burning, let's say it's been burning for, I don't know, around 5 minutes or so at this point, there's no way that that piece of string should still be around. It would have burned to ash and moved on. So we know that it's definitely got to be something else. It's definitely that ball of flame. Let's go ahead and take a look and see how much of this wax has burned at this point. So we waited initially. Let's go ahead and blow the flame out. So I blew it out quickly. We still left the lake of wax in there, so we didn't just spill it. But even if we spill a little bit, it'll get caught inside of here and we'll still have that mass. So it should only be the gas that's burned. So it looks like it did spill out a little bit on the edge here. but that's okay. It's been caught. Looks like we got a little hole in it that formed. So we'll go ahead and put this onto the scale and get our new mass. And so now we have some questions to answer. Good luck, guys.